Hi everyone, my name is Shailesh Borade. I am pursuing my engineering from Government College of Engineering and Research, Avsari Khurda, Pune. Thanks to give this opportunity, my project name is Washing Machine Simulation using PixSimLab. So let's start the presentation. Table of content. Introduction. In introduction, we introduce washing machine embedded system. Embedded C. In embedded C, you use keywords, data types, conditional statement, operators, array, function, pointer, macros. Microcontroller selection. We use PIC16F877A microcontroller. Interrupts, timers. Software requirement MPLAB XIDE, PixSimLab, XC8 compiler. Hardware peripherals we use CLCD, fan, buzzer, and switches. First of all, introduction of washing machine. A washing machine is an essential household appliance designed to clean laundry such as clothing, towels, and bed lines by using water and detergent. It has revolutionized the way people handle daily chores by significantly reducing the time and effort required to wash clothes manually. First of all, introduced in the early 20th century, washing machine have evolved through various technological advancement, from simple manual system to highly sophisticated automatic model. Today's machine after offer features such as multiple wash cycle, temperature control, and energy efficiency, making them indispensable in modern homes. By automating the cleaning process, washing machine contribute to improve hygiene, convenience, and quality of life. Second, what is embedded system? Embedded system are specialized computing system to design the perform a specific tasks within large system. They consist of hardware component like microcontroller, memory, sensor, and actuator along with software that control their operation. Embedded system execute tasks defined by the firmware, interact with the environment through sensor and actuators, communicate with other device or system, and manage power efficiently. They are used in various applications and industries, from consumer electronics to automotive and industrial automation. Types of embedded system. There are two types of embedded system. First, based on performance and functional requirement. Second, based on the performance of the microcontroller. Based on performance and functional requirement, there are four types. First, real time. Second, standalone. Third, network. Fourth, mobile. Second, based on performance of the microcontroller, there are three types: small scale, medium scale, sophisticated. It means large scale. In this project, we use medium scale. Embedded C. Embedded C is a variant of the C programming language tailored for embedded system. It focuses on low-level hardware access, optimizing resource use, and ensuring real-time performance. Programmers interact closely with hardware peripherals, manage resource constantly, and often work within specific compiler environments. Embedded C enable efficient and reliable code development for devices with limited resources such as microcontroller and embedded processor. What are the keywords in C language? There are 32 keywords. It is also called as reserved word. Keywords have a specific meaning and functionality within in the C programming language, and they cannot be used for any other purpose. Data types in C language. First of all, primary data type. Second, secondary data type, user defined. Secondary means derived data type. In primary data type like int, char, float, double, boolean, code, wide character. In secondary data type like array, function, pointer. Third, user defined data type like structure, union, num. Operator in C. We use in this project so many operator. There are an-array operator, arithmetic operator, rational operator, logical operator, bitwise operator, assignment operator, and conditional operator. Conditional statement in C. There are three types: if else, true false, switch. There are three conditions. In if else, there are four conditions: if else, if, nested if. In this diagram, we show the syntax of if, then also syntax of if else. Similarly, if else syntax, nested syntax. And there the condition of switch expression. In condition of true false, the condition is true, the block is executed. If it's false, the another block, if present, might be executed. Define input output pins. There are 5 ports: port A, port B, port C, port D, port E. DDR. There are 5 top DDR: trace A, trace B, trace C, trace D, trace E. Direction of the port is decided by trace register. Trace is the register to which decide the direction of microcontroller, acts as input and output. Trace is 1, it is the input port. Trace is 0, it is the output port. Interrupts. It is a signal which makes the processor to stop its current tasks and proceed to execute a handler set for interpreting sources. Interrupt source. There are two types of source: internal interrupts, second external interrupts. First of all, internal interrupts triggered by internal modules inside the microcontroller comes from peripherals like timer ADC. Example is a timer overflow, ADC conversion complete, etc. Second, external interrupts. It is a trigger by external events like button press or sensor signal. It is comes from outside the microcontroller. They classify in two types: maskable and non-maskable. It is a pin diagram of PIC16F877A. The PIC16F877A, it is a popular 14-pin microcontroller from Microchip PIC family. It features 5 input-output port, multiple peripherals, and it is widely used in embedded system and robotics. Pin 1 is master clear, it is a reset pin. Pin 2 to 7 is a port A input output pins. Pin 8 is VSS, it is a ground. Pin 9 is clock input, it means clock oscillator. Pin 10, it is a clock output, it is a clock output oscillator. Pin 11 to pin 18, it is a port B pin. Pin 19 is VDD, it is a positive supply. Pin 20 is VSS, it is a second ground. Pin 21 to 28, it is a port C input output pins. It is a serial port. Pin 29 to 36, port D, input and output pins. There are parallel ports. Pin 37 to 40, there are port E, input and output pins. Microcontroller application, it is used in embedded system, home automation, robotics. Microcontroller PIC16F877A. The PIC16F877A microcontroller is an excellent choice for the washing machine program because it have a 8-bit CMOS flash based RISC CPU, 8 KB of program memory, 368 bytes of RAM. There are 3 timers, digital input output pins, 10-bit ADC, 200 NS instruction execution. Then the program is fast execute. Timers. PIC16F877A has 3 timer which can use as timer, counter or PWM. There are 4 type: tick, resolution, quantum, scaling. Tick. Tick is based on instruction cycle. Resolution, it is a length of the timer register. Quantum, it is a period of the tick. Scaling, it is the method where we can delay the process of going into ISR if required. Block diagram of a microcontroller, which means washing machine block diagram. This block diagram represents the functional structure of microcontroller based washing machine control system. Input of the microcontroller, power on. It is a switch phi. A switch used to turn on the system send a signal to microcontroller to start the operation. Pause or stop. It is a switch 6. It allows the user to pause or stop the washing cycle. Interrupt the current operation when activated. Navigation. It is a switch 4. It is like used to select the OS modes or option like OS, ring, spin. The microcontroller read this input to change the setting. Door status. It is a switch 1. A switch that checks whether the door is closed. Ensure the machine only operates if the door is properly shut. Microcontroller. It is a central control unit that processes all input signal. It is based on the logic and input. It controls the motor for drum rotation, activate the buzzer for alert, and update the display. Output from there are CLCD display, buzzer, motor. Display LCD, it is show the washing status. User interface for system feedback. Buzzer is sound alert, like wash cycle is complete, error, or door open. Motor. Drive the washing drum. It control depending on the wash cycle selected. This block diagram represents a basic embedded control system for a semi-automatic or fully automatic washing machine. CLCD. CLCD is a dot matrix liquid crystal display. It can be used to display the character, alphabet, numbers, emojis. It is available in different modules like 16 into 2, 16 into 4, 20 into 4, etc. It has 16 columns and 2 rows. It operates on 4-bit mode or 8-bit mode with microcontroller or microprocessor. It have pins VSS ground, VDD plus positive 5 volt VO. It is a contrast control RAS register select RRW read 0 and write 1. EN is enabled. DOD7 is digital data pins. AK is anode and cathodes. Software requirement. We use three software: MPLAB X IDE, MPLAB X8 compiler, and PiximLab. MPLAB X IDE is a robust and user-friendly integrated development environment for designing, writing, and dubbing embedded software for PIC controller. MPLAB XC8 compiler, a powerful C compiler that translates the high-level code into efficient machine-level instruction for PIC 16F877A microcontroller. PiximLab. PiximLab is a real-time emulator of development board with MPLAB X, AVR, GBD, debugger integration. It is a PiximLab development board. This is a virtual simulation board for learning and testing PIC microcontroller based project like washing machine controller. Key points are microcontroller. It is the main controller that processes all input output logic. It is located at the center right of the board. Input devices, keypad. It is used to give the user input. Tactile buttons, configurable switches connected to pins, interrupts and control, potentiometer, analog input connected to ADC channel. Output devices. It is a LCD display, 7-segment display, LEDs, buzzer, relay module, cooler and heater. Other component is a ELM35 sensor. It is read the temperature. EEPROM for storing setting. RTC, it is a real time clock. It is track the time. Reset button. It is a reset button reset the microcontroller. ICSP port. It is for programming the PIC. So let's start the project demo. This is a code. I will explain the code. Here some header file include for washing machine is main.h, clcd.h, timer.h, digital keypad.h. This all the header file are here, but we are micro the header file in main course, which is required for our function and variable. So in void init config function, we are deciding the port direction, fan status, buzzer status, that also initializing the timer and CLCD function also. Here in some washing program, some options are available like daily, heavy, delicates, whites, stain, cotton, bedsheet, rinse dry, dry only. There are options. In water level section, we are using auto, low, medium, high, max, water level section. We are selecting the option type like run time, wash time, spin time, rinse time, and second and minute are variable declared in their washing machine for countdown operation. And here is the program number which are selected here, daily, heavy, are declared in program number variable. Now in main program, first of all, if you open the MPLAB XID, here is the board selection option. Here we select first PickGenius board. Then we select the microcontroller. This project we use the P16F17887A microcontroller. Then we select the display 1604. Then we select the clock frequency of PIC microcontroller. Then we want X file to run this project. First of all, we insert the file in PicSimLab. So file load X, here is the file which I was already generated this file. Here press key 5 to power on washing machine. This message is show on display. In first way, show the line 1, line 2, line 3. These are the lines on LCD display. There are 1, 2, 3, 4 lines are available, and 1, 4 and 1, this is a position of character. Wait for 3000 millisecond, that is a 3 second for power on screen. In power on screen function, in this function we are return powering on washing machine string, and it is show on display. After press switch 5. Now washing machine program function. In washing machine program function, it is the display the washing program display reset function. If the key switch 4 is pressed, then the program is incremented. After if program number 12, it is the last program number. If you select the program number 13, then it is goes to the program number 0. It means program number 0 is daily. LCD display the washing program and star indicate the what program we selected. In set time function, we are using a switch statement and program number function. It is included in switch statement. Case 0, what program is executed defined in second and minute. These two things decide the motor on or off condition. Now in run program, we display the time and program function. What function we are use in program? Like if I long press on switch 4, then the washing program daily is selected. Now I select the outer level. If I again long press on switch 4, I will select the auto. Now, after pressing the switch 4, then switch message display on LCD. Switch 5 for start and switch 6 for stop. Now, in our code, we wrote the like this switch 5 for start and switch 6 for stop. If I will press on switch 5, then timer will be on and fan is also on. Similarly, operation mode function it also on. Press switch 6, then it will goes to the washing program display screen. Now I will show you. If I will press on switch 5, then program will be started. Time is down counting and fan will be start. If I will press on switch 6, then program will be stop. If I press switch 5, program will be start. Now here we using one another function, that is door status check function. If RB0 means switch number 1 press, then it will be show the fan door is open. That time the fan is off and time is also off, but buzzer will be beeps. And LCD display the message door is open, please close, and it's continuously executed. If door is not open, the washing machine display show the function, timer, start and pause, and other remaining program. If I select the function, short press is change the function, but long press is select the function. I select delicates, then I will select the auto level. Now I press the switch 5 to start the program. Now I will select the program is delicates, function is osh, timer countdown is start. If I press the door status check button, it display show the door is open, please close. Then the door is closed. The remaining countdown time it will be started. Yes, program will be completed. Remove clothes. Show again display washing program. Conclusion. This project successfully demonstrates the design and simulation of a washing machine using a PIC16 F877A microcontroller. Key embedded system principle were applied to control real-time process using timers and interrupts, interface hardware peripherals like keypad, CLCD, buzzer, and fan. Provide a user-friendly interface with mode selection, auto level configuration, and process feedback. Thank you.